A number is usually used to identify how many units of a quantity or how much of something you have. A numeral is the symbol we use to represent a number. Counting numbers can be used in two different ways. I can say, I have 25 apples. That would be use of the number as a cardinal number. However, if I say first, second, third, I'm using the numbers to order items, and that's referred to as ordinal numbers. So for example, if I look at the 25th page in a book, that would be an ordinal number use. If I say 25 pages in the chapter, now you're using it as a cardinal number. Numerals can also be used as labels like telephone numbers or social security numbers, and that's similar to using letters to represent things or labels. So here's your first video log question in this lecture series. Use that project you did where you looked at 25 different places in your real life and numbers where you encountered them, and label each one of those 25 instances of numbers as cardinal number, ordinal number, or as label. The next part of this lecture will deal with categories of numbers like whole numbers, integers, and so on. So let's go to the next part of this lecture. So for categories of numbers, we're going to introduce the name of the particular set of numbers, and you want to make sure that you memorize these names and what numbers belong to that label. So for example, the label of natural numbers is associated with numbers like 1, 2, 3, 4, 5, and the letter N represents the set of natural numbers. We use the letter W to represent whole numbers. Whole numbers are all natural numbers along with 0. Integers are all whole numbers along with their negative counterparts, and we use the letter I or Z to represent a set of all integers. Set of fractions or rational numbers are all ordered pairs A, B, and we write them as A over B, where the denominator B is non-zero and both A and B are integers. For example, negative 2/3, 5/3, those are all examples of fractions, or even 5, which is 5 over 1 or 4 over 1. Those are all examples of rational numbers. If you write rational numbers as decimal numbers, then they have to be terminating decimal numbers or non-terminating decimal. That means infinitely many digits after the decimal point with repeating pattern. So for example, 57.125.125 repeating can be written as 57 point and then 125 with a bar over its head tells you that the 125 is repeating. So 4.3 bar over the head would mean 4.333 repeating. So again, all rational numbers can be written as decimal numbers that are either terminating decimal, that means they have finite number of digits after the decimal points like 1.34, or non-terminating decimal number with repeating pattern. Repeating pattern is important, otherwise you do not have rational numbers, you have irrational numbers. Irrational numbers are all numbers that are not rational. You will get extra credit points if you figure out when first irrational numbers were talked about in the history of mathematics and what stories go with the discovery of irrational numbers. So irrational numbers are all decimal numbers that are non-terminating with no repeating pattern. Non-repeating means infinitely many digits after the decimal point with no repeating pattern. If you look at this number here, 4.31, 311, 3111, there is a pattern, but it is not a repeating pattern, 3131, 3131. So this is an example of an irrational number. Square root 2 is an irrational number, pi, e, those are all examples of irrational numbers. The set of real numbers is formed by the union of all rational numbers and irrational numbers. The set of complex numbers is set of all ordered pairs, again A plus bi, where the I represents square root -1 and all numbers that are of the type square root -4, which is 0 plus 2i, or -2/3 minus 0.3i, or 31 minus 0i are examples of complex numbers. As you can see here, if the imaginary part, which is the part that belongs with the I, is 0, you get all real numbers. If you have 0 for the real part, then you just get all imaginary numbers. So complex numbers have two parts, real part, imaginary part. So here is a summary of how the numbers fit amongst each other. So here's a summary of how the numbers are related to each other. The way we're going to display them here is called Venn diagrams. It will give you a visual sense of how the numbers are related to each other. So we started with counting numbers or natural numbers, which are 1, 2, 3, 4. Then we looked at whole numbers, which is natural numbers together with 0. Then we have integers, which include all whole numbers and their counterparts, negative counterparts. So like -1, -2, -3, 0, 1, 2, 3, and so on. Then we have rational numbers, which is fractions. So A over B format, where A and B are non-zero integers. So for example, 2 over 3, 4 over 5. Oh my God. Okay, start over. Let's look at a visual display of how the numbers are related to each other. The way we're going to display them is called Venn diagrams. So natural numbers are counting numbers like 1, 2, 3, 4. Then the next part would be whole numbers, which is 0, 1, 2, 3, 4. So you can see natural numbers sit inside whole numbers. Then whole numbers and natural numbers sit inside the set of integers, which is positive and negative whole numbers. And the whole integer set sits inside of rational numbers, which are fractions like 2/3, -4/3, and so on. So A over B format, where B is a non-zero integer and A is any integer. Then we have irrational numbers, which we saw were like square root 2 or non-terminating decimal numbers with no repeating pattern. Together, rational numbers and irrational numbers form the set of real numbers or decimal numbers. And then we have complex numbers, which are of the form 2 plus 3i. So they have a real part and an imaginary part. And so you can see how the numbers are related to each other. So all real numbers are also complex numbers, but a number like 2 plus 3i is a complex number, but not real number. So here's the next set of questions that we would like you to think about. Can you think of an example of a whole number that is not a natural number? Can you think of a number that is an integer but is not a whole number? Can you think of a rational number that is not an integer? Can you think of a complex number that is not a real number? So spend some time thinking about the questions that we have. For bonus question, think about, is there a number which is a real number but it is not a rational number or an irrational number? So the last question for extra credit or bonus we want you to think about is, can you have a real number that is neither rational number or irrational number? So here's your next video log question, which is looking at your real life world when you leave classroom or after you finish with this lecture, and keep track of all the places and things where you see numbers. List all the numbers that you see on either license plates, on weight of an object, calories. Wherever you see numbers, write them down and get at least 15 or 25 numbers in this manner. and categorize them as using the labels that you have just seen. The next set of questions is displayed here. We want you to spend some time looking at these questions. If you're using it for a class, then you probably have these questions already in your textbook.